Hi students, today our topic is on your unit 2, that is in physical quantities. So in your unit 1 we have seen what is a physical quantity. Any quantity which is measurable is called as your physical quantity. So how do we represent a physical quantity? By its numerical value followed by its unit. So an example, height of a person is 6.2 feet. This 6.2 is your numerical value and feet is the unit which we use to measure your physical quantity. So your physical quantity can be classified into two. One is your scalar quantity, the other one is your vector quantity. So first let us see what is a scalar quantity. A quantity which has only magnitude is called as your scalar quantity. So it does not have any other thing, it will just have its value. Magnitude means a number or the numerical value, it's called as your scalar quantity. So some of the examples of scalar quantities like area, volume, height, breadth, distance, speed, all these are your scalar quantity. So in your scalar quantity, you can add, subtract, multiply and divide by just using your normal arithmetic ways. It does not require any special laws. So this is about your scalar quantity. So the scalar quantity values, these numerical values can either take positive values or it will have no value, that it can be 0, but it can never take negative values. So it will always have positive or it will take no value at all, but it can never take 0 value. Now come back to your vector quantity. So in this you'll have a special category that it has magnitude plus direction, in which way the particle is moving will be denoted. So it will have magnitude plus direction, so that is called as your vector quantity. So scalar means it will have only magnitude, whereas magnitude plus direction means it is your vector quantity. So your multiple, that all your arithmetic things has to follow some rules for it. It has a special law and it will stick on to work with your vector algebra. So all your arithmetics cannot follow your normal mathematics, that you cannot add or subtract or multiply, divide just by that. It will have certain laws, we have to follow them, and that is called as your vector algebra. So I have to differentiate between my scalar and vector. So in order to do that, either I will write my representation with an arrowhead on it or with a bold letters. I can go for letters like this. So a vector representation will have an arrowhead. Okay, it will have an arrowhead, whereas your scalar you can just write as such. So over in your scalar we saw it can have only positive values, whereas in case of vector it can have positive, negative and 0 values. So this is a brief interaction between your scalar and vector. Your scalar can have positive values, whereas your vector can have positive, negative as well as 0 values. So now we have seen a classification of physical quantity in terms of the magnitude and direction. If it is going to have only magnitude, it is scalar. If it is going to have magnitude plus direction, if I am able to say in which direction my particle is moving, then it is your vector quantity. Our next topic is on rest and motion. So rest means an object stays to be in a state of not moving from one point to another point. We call it to be as rest, and if the object tends to move along any direction in a given space, we call it to be as a motion. Then what is the link between rest and motion? Everyone, even every object in this earth is actually moving, because your earth is moving along the sun. So it doesn't mean everything is rest. So it is with respect to the observer. So for me, whom I'm sitting inside a car, if my car is moving, I will feel all the houses and all the trees which is moving against me. So I am in a state of rest, whereas these objects are moving against me. They are moving beyond me. So they are moving, but I'm in rest. For a person who's standing outside and watching me going into the car, for he will note that I am in motion, whereas he is in rest. So rest and motion, it is with respect to your observer. So based on this of your motion, you'll have three different, that is one dimensional, two dimensional and three dimensional motion. So first let us see what is a one dimensional motion. A motion which is along a straight path or a straight line is called as your one dimensional motion, which means it is along any of your axis. Either it is moving along the x axis or y axis or z axis, but it is not moving at all directions. So that is your one dimensional. One dimensional means only at your x-axis or only at your y-axis or only at your z-axis. So which means that is your one dimensional. It is moving in along only one axis. It's called as your one dimensional. There is no lateral direction motion. So it is not going to move along both the cases. Okay, that is your one dimensional motion. So example, consider a car which is moving on a straight road. It is moving on a straight road. So I'm going to plot a graph. For time t is equal to 0, it is at one particular position, and for 1 second, so it has traveled a distance of like 1 meter, and for 2.1 seconds 2 meters, and 2.5 3, and 3 seconds it has covered 4 meter. So it is along a straight line path. So this is an example of one dimensional. And you can also consider in this way, you're just dropping a ball from a particular building, and the ball is just traveling along the length of the building. It is just falling straightly down, which means there is no other direction involved except only one particular direction. So again, for each time you see how many distance it is going through, and this is an example of your one dimensional motion. So one dimensional motion can also be called as your rectilinear motion. It can be also defined as your rectilinear motion. The motion which is along a straight path is called as your one dimensional motion. So our next topic is about distance and displacement. You have come across both the words so far in your physics, distance as well as displacement. So we will actually see what is the difference between them. So distance is the actual path between any 2 points. So if I want to travel between A and B, the exact path which I am supposed to take is called as my distance. So it does not have any specific shortcut to travel. So it does not have any direction. Therefore, it is a scalar quantity. Since it is just a length between any 2 points, okay, the SI unit is meter and the CGS unit is your centimeter. Now come for displacement. Displacement is the shortest path to achieve between the starting point and the ending point. So that is called as your displacement. So I can take any direction to complete it. So that is the difference between your distance and displacement. Since it involves a direction, it is called as your vector quantity. So again, it's nothing but a unit of length. Therefore, its SI unit is meter and the CGS unit is centimeter. So in order to represent a displacement, I'll use the word F along with your representation for the vector quantity. So the representation for vector quantity is your arrowhead, which we will use it. Next one is your representation of your vector quantity. So here we will just consider for your displacement. So vector quantities means it will involve all the directions, okay, your north, south, west and east. If the particle is moving towards east direction, the particle is moving to the west direction, or it is in between your northeast or northwest, so we will mention it is moving 30 degrees of northeast. So that is how we will use to mention your vector quantities. So now we will see representation of your displacement. So consider this is your origin point and this is your terminus point. That is the where I'm going to end it. If a person starts from the origin and if he's going to end at Q, I'll draw a line in this direction and I'll indicate my arrowhead. Okay, so it indicates that he's starting from the point P and ending at the point Q. So now he is going to go the other way, such that he is going to start from Q and end at P. Therefore, Q is my origin and this is my terminus point. Okay, so starting from here and he's going to end at this point. So this is your terminus. Therefore, he is going opposite. So I will draw my vector in this direction, or else I can also represent negative of my PQ. This is opposite to my this one, so I can draw a line. So this negative comes, it indicates it is going opposite to this particular direction. So this is how we will represent a displacement. So now consider an example for understanding distance and displacement. So this is O, A and P. A person is starting from a point O and he is traveling 4 kilometers. That is OA. So from O to A he has traveled 4 kilometers, and from A to B he has traveled 3 kilometers. So this is your actual distance. So actual distance is OA, and from OA to B, so 4 and 3. So what is the total distance he is traveling over here? He has traveled, that is 4 plus 3 is 7. But actually I want to travel O to A. Therefore, can you take the shortest path, that is OB? So if I take OB, it will come as your 5 kilometer. using your Pythagoras theorem, I can obtain this value, that is my 5 kilometers. So this is called as your displacement, the shortest path to achieve your end. So that is called as your displacement. So you will understand distance is 7 kilometer and displacement is 5 kilometer, and it is moving along your northeast direction. So from this point you just draw your vector representation. You will find it is along your northeast direction. So take this point as your origin, west, east, north and south. You will find this is northeast. So the displacement is along the northeast, and how many how many kilometers you have traveled? 5 kilometers. Therefore the displacement is 5 kilometer and the distance is your 7 kilometer. You'll always have to understand your distance and displacement can be equal, and distance can be greater than displacement, but distance can never be less than your displacement. So understand, your distance can be equal to displacement, your distance can be greater than your displacement, but it can never be less than your displacement. So for this you consider an example AB. Okay, so the distance between the point A and B is 5 meters. First, a person is traveling from A to B and from again B to A. So if he travels from A to B, it is 5 meter, and again is going from B to A, which means he is going in the opposite direction. Therefore my displacement will become minus 5. Therefore the total displacement here is 0. So you can always get a value which is less than, but it can never exceed. So understand, your distance can be equal to displacement, your distance can be greater than displacement, but it can never be less than your displacement. I'll put in the other way. Let us calculate the distance and displacement. Okay, traveling from A to B, how many meters? 5 meters. Displacement is also 5 meter. So that is your first case, traveling from A to B. Now I'm going to travel from B to A. So B to A is again 5 meter, whereas in case of displacement it is minus 5 because it is in opposite direction. Now you total this, okay, AB from B to A, if you total is it is 10 meter, whereas over here it is 0. So now can you understand, your distance can be greater than your displacement, but it can never less than be your displacement.